All right. Thank you very much and welcome everyone here at IIT Palakkad and both Mr. Mani Iyer and Dr. Ramesh Gopinath for joining us today. Today's talk is on blockchain. The Friendly Fundas video series is a video series organized by the friends of IIT Palakkad, well-wishers of IIT Palakkad all over the world. Today we have Dr. Ramesh Gopinath with us, and he's going to talk to us about blockchain. I first heard about blockchain when I was looking at bitcoins, and then it really hit home when John Oliver, I think, did a session on blockchain and cryptocurrencies on his last week tonight, comedy thing on YouTube. I caught it on YouTube. So I guess this is really going to be the next big thing, and I'm sure the students and personally I will definitely enjoy this session. So to a more formal introduction, as you all know, the Friendly Fundas video series is hosted by Mr. Mani Iyer, and Mr. Mani Iyer did his bachelor's in electrical engineering from IIT Madras, and then did his master's in computer science from the University of Wisconsin-Madison, and then subsequently worked at Oracle. He was a founder of a company called Teamscape, and then right now is the CEO and founder of Kwanzoo Inc., which is the best-in-class adaptive account-based marketing tool and does web analytics and sales insights. Thank you very much, sir, for your continued interest in this and great support. And thank you very much for organizing this. Our speaker today is Dr. Ramesh Gopinath. Dr. Ramesh Gopinath did his B.Tech from IIT Madras and subsequently an MS and Ph.D. from Rice University. And he's been with IBM for quite a long time. He began his career in IBM research in 1994, and over the years has led the development of IBM products and services in a broad range of areas, including cognitive, that's speech and text, collaboration, mobile, and cloud. Right now, he is responsible for offering management and development of blockchain solutions at IBM. He leads client engagements in this space and has worked with marquee clients across a number of industries, including food safety, banking, financial services, and the global supply chain. He's played an instrumental role in developing the IBM Food Trust blockchain to support food safety, and this is in use across by many of the world's large retailers and food companies. He's also developed the trade lens technology used in numerous shipping companies dealing with supply chain management. So thank you very much, sir, for joining us. It's a pleasure.
All right. Thanks, Arvind, for that very nice introduction. We really appreciate it. Again, my name is Mani Iyer. Glad to be with you all, students at IIT Palakkad. I know you guys, I was just told, are about to have your final exams, so we appreciate taking an hour out to come and listen to us and talk to us. What we'll do first, just to set the background, we do these Friendly Fundas interview video conversations with, some of the best of IIT alumni around the world. And as I've said before, the goal of each of these interviews and talks is to 4 words. Remember, get your fundas straight. So we're trying to help you get your fundas straight on a whole new topic here, which is all around blockchain solutions. As always, we'll start with some background questions for our guest speaker and try to learn a little bit about his career arc, if you will. And then from there, we'll get into certainly, some very fundamental technology topics. So Ramesh, first of all, welcome.
Thank you. Thanks for having me here.
Yeah, so Ramesh, if you don't mind, can you kind of start by telling us a little bit about, where you're from and where did you go to high school? And
so I'm originally from Palakkad, and my parents live just a stone's throw away from IIT Palakkad. They live in Sultanpet. Okay, so very close. I wish I was there. So anyway, but I grew up in Tamil Nadu. So in terms of high school, I was in multiple cities, in Ooty, in Coimbatore, and finally in Madurai, where I did my high school. My high school was at a place called Railway School, which is basically a school run by the Indian Railways. And from there, I went to IIT Chennai to do my undergraduate. And I was the first student, as far as I know, from that school to ever go into IIT. Okay, so that was an interesting thing. The other
Wow.
thing is,
I'm sure.
yeah.
I'm sure that was groundbreaking, path-breaking for you when you went from that small high school in Madurai to IIT.
Yeah, and I didn't realize the sort of the import of it till I got to IIT, because the other interesting thing was, I'll just give you two interesting things about my getting into IIT, and then I'll give you my full story in terms of where are the key places I've been. So in terms of joining IIT, I did not take any courses like Agarwal or Brilliant, because I didn't know about much of these things. So that was another interesting twist. So when I went to IIT, a lot of people like, you really got in without going through coaching classes. That was an amazing expression that I got to see in IIT. The other interesting thing was when I did the IIT exams, right? You have 4 exams you take: math, physics, chemistry, and English. After the math exam, I had only attempted about 35%. That's it. I knew I had only attempted 35%. Forget about the remaining, but I had not even bothered to touch them. I went back home and went to sleep, believe it or not, right? Saying, I'm done. I'm not going to bother with the English test. Even today, my mom teases me. She woke me up and said, get out of here. You're going to go do your test, right? And that's basically how I got into IIT, so just to let you know. In terms of IIT, basically, the first year I worked my butt off, literally speaking, and so I joined in electrical power, and I wanted to get into electronics, which was my passion, which I did. At the end of the first year, I did get a branch change, and then 3 years on, I goofed off, had a good time. Fortunately, as part of that entire journey, I got very interested in signal processing, right? And there's a lesson there also. Basically, you get excited by what is the hottest thing of that time period, right or wrong. Later on you realize maybe it's typically wrong, right? So what happened was I said, okay, I've got to work in signal processing in fast algorithms. The professor who is best in this area is a guy called Sidney Burris in Rice University. Sent him a letter. So in those days, you used to write letters and with pen and paper and stuff like that, and got into Rice University and started my PhD. I'll just fast forward quickly. PhD was done. After that, I got to IBM research. At that point in time, there was a lot of work going on in speech recognition at IBM. So I joined the speech group under the famous Fred Jelinek, who is no more. And joined the speech group there. Worked in speech for like 13 odd years, and then and then from speech recognition, I moved to a few other areas. So I was doing AI before all the hype in AI. Let me put it that way, right? And then after that, after the work in speech, touched a few other areas. Eventually, I ran IBM research in India from 2013 through 2015. So I was in Bangalore for 3 years, running the lab in Delhi and Bangalore. So I have a good sense of the IITs in India to these days, right? So I had a good sense of that. And then I came back to the US, and there also, serendipity plays a huge role in life, right? So what actually happened was there was a small group of people who came in to my office and said, blockchain is going to transform, all industries. You got to pay attention to this thing. Over time, I got convinced, and then I got to convince the entire IBM leadership, starting with the CEO down. And then we began a journey in blockchain from IBM research, actually, in 2015. And I've been working in this area since then. And the amazing thing is IBM at some point in 2016 decided this is so interesting, exciting that we're going to form a new business unit. And when that was formed, I moved with the team that I had in research. So I spent all my career in research, and now I'm running, a business, if you will, right? At least a tiny chunk of, what IBM does. So that's a quick, run through what I've done, right? From high school to IIT to Rice University to IBM research for 22, 23 years, and now in the business unit within IBM running blockchain solutions last 2 years.
Wow. Okay. Yeah. No, that's a really interesting kind of a journey there that you've gone into, and I know that a lot of the students, at least, have had questions for us in the past about, how do you make some of these choices? But it sounds like for you, it was just it just so happened that you finished IIT, and did you ever consider working in India, or was it pretty easy for you to say, you know what, I'm just going to head off and keep studying and then go to Rice University?
Yeah, so like I mentioned earlier, right? So one of the things was, I'm driven by what I find interesting. And my interests are varied also. That's the other aspect to it. Some people are very focused on specific areas. It's not like I want to do quantum physics and I know exactly what I need to do. In my case, I was very excited by the work that I did in my undergraduate project in IIT Chennai. It turned out it was in something called fast Hartley transform, right? So during those days, you may never have heard about this. There is this thing called a Fourier transform that powers a lot of things out there, right? So that was an exciting thing. And so I learned that, then figured out who was doing the best work in that space, and made the leap to, so that it was a natural progression for me to just figure out where to, go study this. And it turns out to be Rice University, so I went there. But one quick point I want to make there, which is, even though all that excitement took me there, within a year of trying to, beat my head against the wall, if you will, trying to do the next best thing in fast algorithms, what you realize is, the area may be extremely mature, and you don't realize it as as an undergrad, right? So very quickly I realized I'm not going to be able to do something exciting and interesting in the fast algorithm space, and so I had to move on. So in my PhD thesis, if you will, the master's was in itself. I decided to switch areas, still with the same professor. It was not fast algorithms anymore. It moved into a new area which was very popular then, called wavelets. Some of you may have heard about wavelets and filter banks, and that's where I did my master's and PhD. So it's kind of interesting that you start with an idea, but you have to also be cognizant of the fact that a hype of today, like blockchain, may not be the place that's going to be hot tomorrow, right? So you got to be willing and flexible to change. But as long as it's something you're interested in, it all works out.
Okay, all right, good to know. So before we get into blockchain, let me get your views on, and because again, this is something the students have brought up as a question in the past, is did you look at, just broadly, can you give us a bigger picture at IBM? I mean, what are some other key areas which IBM research you believe considers the frontiers of technology, computer science? Are there different areas? Because even in your own background, I can see that you've done cognitive into the speech and text, you've done some collaboration, mobile, cloud. If you just look back at your 15 years of research, are there areas other than blockchain you think that would be interesting, exciting for the students to be thinking about?
Yeah. So I think some of the areas that are extremely interesting and where tremendous progress is being made are things like artificial intelligence or machine learning, broadly speaking. In fact, I can give you a personal anecdote in this area, right? So I'll start there. Let me first cover a few areas. AI, Internet of Things, right? Sensors, sending data, because data has to come in for somewhere for AI to work with. Blockchain is certainly an interesting area. Quantum computing is making leaps and bounds these days, right? And it's quite amazing to think about, a quantum computer that, a layperson can go online and try to play with, right? We have that running from IBM for the last 2 years. So there are plenty of interesting areas, some longer term, some near term. Cryptography is another area which I think is extremely important and is getting even more important, right? If you think about all cybersecurity as a problem that is faced, right? Everything is done online, even in India, right? I was there for 3 years, last 3 years. It's mind-boggling how the internet works if you think about it, because so many things can potentially go wrong. So the latest and greatest trends in cryptography and stuff is another area that I think is extremely important. But AI anecdote I wanted to tell you about earlier, right? Let me just quickly get to that. So I spent like almost 13 to 14 years doing speech recognition at IBM research. I was super happy doing the work. We were probably on the bleeding edge or cutting edge in the technology. Even now that team is one of the best in the world. What we did, and then a lot of that body of work, if I think about it, if I look back, are relatively, I would say, obsolete already, right? I've been out of speech for maybe 10 years now. Why is that obsolete? A lot of it had to do with the advent of deep learning and it changing the way in which speech recognition is being done today, right? And so that's an example of, so if I look back, we were on the cutting edge, but guess what? It's all obsolete already, right? So my life work, if you will, for 13 years it's irrelevant now altogether, right? But when we were doing it, it was the best algorithms out there. Right? That's one interesting lesson about nothing's changed. The second lesson is a lot of what people say see in AI, like deep learning people talk about. But that idea has been around for a very long time. It's just that today the compute power and the data available has changed so that people are going back to the old ways of doing things. Yes, Jeff Hinton made it very popular and all that, but the reality is, even in speech recognition as an area, so let me just simple way how speech recognition works, right? Your words have to be converted to text. So whatever I speak has to, audio has to be converted to text. So there are two sources of information people use. One is, prior knowledge about, how words come out, right? This is a language model, as people tend to call it. That gives you some information about, if I said, a few words so far, what is the next word likely to be? That's one source of information use. The second source is called the acoustic model, which is, a model for given words, what is the acoustic waveform or the sound signal going to look like, right? You build an acoustic model. You look at the two scores, the acoustic score, the language model score, and you combine the two and say, okay, this is what the person was speaking or saying. Now, even then, we're going way back to the late 70s when speech recognition got its real push with hidden Markov models and stuff like that. What is well known is the best way to model the acoustics is by modeling the words given the acoustics rather than the other way around. In other words, use a direct model rather than a generative model, to use technical terms a little bit here, right? And the best way to do that even then was neural networks, right? So people did know the right approach to do it is that way, but there was no compute power or ability to run deep neural networks, and that is the reason why it was never used. So I spent 20 years with the generative model approach, building Gaussian mixture models to model, the acoustics, and which was great. And by the way, we did a lot of interesting work. It was exciting. The work was challenging, but all of that somehow has been irrelevant now.
Got it. Okay. So certainly sound like you see several different areas. You mentioned speech, you mentioned IoT, you mentioned quantum computing and so forth. Let's get to the key topic at hand, which is what the students want to hear about. As you said, there's been a lot of hype around blockchain. I'm going to put up a slide on blockchain, the one you sent me.
Yeah.
And why don't we start with the very basics for the students about what exactly is blockchain?
Yeah. So blockchain got popularized because of the work on Bitcoin, right? Which is a very interesting, if you want to call it, technology plus an ecosystem that built around it, right? So for those who are not familiar with Bitcoin, essentially this is, think of it as a bunch of computers that work together to help people send payments from one to another, to do transactions between parties, right? Bitcoin is some sort of a virtual currency that sits on this Bitcoin network, and people send transactions back and forth. The most interesting idea there is this notion of, you can have a trusted, immutable way of doing those transactions. So if I pay something to money, it's forever etched in the blockchain. That's the way the Bitcoin blockchain works. But the insight that basically we took from there was, it is at the end of the day, blockchain is a database. I mean, in fact, that's the simple way to think of it. It's just a database. It has got some interesting properties that make it very interesting. The properties that make it interesting have primarily got to do with the fact that it can be trusted by parties, right? Multiple parties, multiple companies, multiple people, whatever, right? That what is in the blockchain can be, is trusted. And why is that? One is any transaction that gets into this database. So somebody sends a transaction to it. It's done with digital. It is digitally signed so that you know who did the transaction. So in other words, the property of non-repudiation, right? If you send a transaction, you can't say I didn't do that. So that's one interesting property. The second property is the database itself is immutable, and there are technical reasons why it's immutable or virtually immutable. But that's not the interesting piece. The interesting piece is things in there. It's like writing with pen, right? Doing a crossword with pen. It's written with indelible ink, so you can't erase things. So things are always there, which means you can use it for business processes, right? What do I mean by that? Imagine a simple scenario. There's a buyer or a retailer. I don't know, pick your favorite retailer in Palakkad. And there is a supplier who is supplying some goods to the retailer, right? As the goods, so there is an order placed and a bulk shipment happens and it's delivered. Three parties are working on this. The trucking company that takes stuff and delivers it to the buyer and the seller. Typically, the way in which it's done is like what is shown on the left-hand side, where parties send in, messages back and forth, right? I put a purchase order, I get a shipment notice from the other side, I receive the goods, etc. In this way of working, point-to-point communication between businesses or companies, you run into this issue of disputes around, oh, the goods were damaged when they were delivered, etc., etc. When that happens, the way in which they solve, it doesn't matter which part of the world you are in, whether you're in India, the US, it doesn't matter. It's done by phone calls and emails and so on and so forth. That's how it works today. If you move to the model on the right, with this new database that's immutable and which has this property of non-repudiable transactions, what you can do is that entire sequence of actions that the three parties make, the buyer, the seller, and the company that's carrying the goods, you capture the activities they do as transactions in a workflow, and these workflows are typically called smart contracts in the blockchain world, but it doesn't matter what they're called. At the end of the day, it's basically, think of it as a sequence of transactions that are interwoven together or linked together. But if each of those transactions are completely trusted and captured on the blockchain, what it means is when something is delivered, right? At that point, you could imagine taking a picture of it or something like that, that gets registered on the blockchain. So, disputes around damaged goods either cannot happen, or if they happen, it'll be legit, you eliminate disputes basically to the extent possible is the idea. So essentially the crux of the idea is move from a point-to-point communication that leads to silos of information and problems around that to a model where basically parties basically interact by sending information to this trusted database called the blockchain, and then significant business efficiencies can happen. By the way, it's a big leap from what the Bitcoin blockchain did to coming here, because there is an analogy here. The Bitcoin blockchain also is a database which was used for payments between parties, anonymous participants who don't know each other. Right, so that's why there is a lot of excitement around the Bitcoin blockchain. To no questions, it's a great, interesting innovation. But there is a simpler problem you can solve for businesses that are working with each other by using this technology to literally use it as a distributed database with certain trust properties, right? That enables you to do business more trusted fashion. Very simple idea, and there are a few concepts around it, but I think the essential idea is think of it as a database that I can trust, where I can send information, and the information will stay there forever, and I can't, if I send the information, I can't deny that I sent the information.
Absolutely. Now, would you say that, again, for students who are new to this whole area and they're learning the, even the basics, let's say, of computer science and principles, some first principles, I'm assuming some background around databases, relational databases, structured data, concurrency, transactions, all that's obviously goodness, right, for them to start to understand this area.
Yeah, to understand this area, I would say, database technology would certainly help. But in another couple of other key areas that are critical to understand how the underpinning of blockchain works are cryptography is crucial, right? Remember I said it's a trusted database. Much of the properties of the trust comes from interesting cryptographic techniques. And by the way, cutting edge work is happening in that space. I'll give you one example, right? There is something called zero knowledge proofs, which is a way of parties to essentially, I need to prove something to you, money, but I do that by just proving you without saying anything more, right? You can read it up on Wikipedia what that really stands for, but that is being used today, for example, in blockchain-based smart contracts. Very interesting, cutting-edge ideas. A lot of the original work in the space, by the way, also traced back to the cryptographers that IBM researched many years ago. So there's cryptography is key. Databases is key. And the third, I would say, is just distributed systems in general, right? Because the trust in the blockchain comes from, a few things that I didn't touch upon. Maybe I'll just quickly touch upon. How does the trust come about, right? It's a good question to ask. One is non-repudiation. I mentioned digital signatures, right? When you sign and send it. The second is there are multiple copies of this database, right? So effectively, if one copy is tampered with, it becomes inconsistent with all the other copies, and the next transaction cannot happen, right? All copies have to be consistent before you can make the next step, right? So redundancy, is another element. And the third element is something where the transactions are chained together, blocks of transactions are chained together, and that's where the name blockchain comes from. Some sort of a digital fingerprint of, say, one block of transactions is added to the header of the next block of transactions. Again, the key idea here is if you have some sort of a chaining, if somebody has to tamper with a certain transaction, they have to then fix all the following transactions too because of this chaining effect. So that's a lot of work to do. So it's harder to tamper with.
Absolutely. So, as you know, I went to school at Wisconsin, and it certainly was, well known for being a very strong system school, meaning all around, databases and distributed systems and so on and so forth. And databases, I'm sure you'll agree, is a more mature technology area. There's some very good textbooks, books, things that people can read. What do you have any specific? And again, you mentioned, can you, if you can maybe cover that again, just reinforce that as to where students can go look up information. So one was around cryptography. What are the key concepts, certain words, certain things they can Google on to find information on, say, Wikipedia and elsewhere, like you said. And the second is, again, around blockchain, if you can mention any key resources that people can go look up.
Yeah, so I think since much of the work is happening in near real time, the best source is online. And, just doing a Google search on, blockchain is too hype. Maybe blockchain or distributed ledger technology would be a couple of things I do, and that would give a tremendous amount of information that is sort of relevant. The other thing to keep in mind is there are two, it's a tale of two worlds, let me put it that way, right? So it's important to understand the distinction between the two. And maybe if you go to the next page, Mani and I may help me explain that, right?
Okay.
So essentially, if you think about this database called blockchain, right? There are some key questions, right? In a database, who operates or runs the database is one question you need to answer. And the second question is who can send transactions to this database, right? If both of them can be potentially anonymous participants, right? Then you are in a world called permissionless blockchain. This is a name that you'll sometimes hear when you look online. That is the world of Bitcoin and Ethereum and all that. And when you have a database that's managed by anonymous participants who don't know each other, you have to come up with ideas, some incentive mechanisms to make sure they run the database. That's why you run into things like cryptocurrencies, Ether, Bitcoin, etc., etc. It's a construct required to run the database. Yeah, and then you have all sorts of interesting, cool things happening in the world of permissionless blockchain, like initial coin offers and so on and so forth. You can read it up. There's a second world which is very different from that, where you're talking about really the players who are managing or operating the database are known parties. Very different, right? They're not anonymous anymore. These are called permissioned blockchains. So there are two worlds, permissionless blockchains and permissioned blockchains. Very important to understand. In the permission world, by the way, these are the blockchains that are getting traction in business today. The reason is simple. If you're running your business on top of a database, if something goes wrong, and always with software something can go wrong, either it could be a security issue or it could be something failed, or if people there was buggy code, right? So when something goes wrong, you need to know who is running the database, and so fall back on the legal system if something goes wrong. That is possible in the world of permission blockchain, and that is why most big companies like the IBMs, Microsoft, SAP, Oracle, what have you, all of them are really doing a lot of work in the world of permissioned blockchains, where you don't hear about cryptocurrency, bitcoins, and ether and all that, but you're really talking about an interesting new database with some interesting new properties that is used to solve business problems.
Got it. I think I get it. So really, people should be, the students should be thinking about, are they more excited about cryptocurrencies and how they are deployed with blockchains, and understand the whole idea of Ethereum and Bitcoin and all that. So that's one way they could go. The other is to learn all about blockchain as a fundamental building block of technology, and how you can do, as you said, have transactions occur in the business world, and then they can look at blockchain for business, which doesn't have cryptocurrencies necessarily involved. But there's some very fundamental building blocks of technology being built by these standards groups like Hyperledger and the Enterprise, the Ethereum Alliance. So students, hope that helps you. That's really what Ramesh you're recommending, is a couple of ways to go and diving into this and trying to understand one aspect or the other. Because it's a lot to get into, right? It's a lot of information. You'll have to pick and choose, maybe, or drill down. So sounds good. So Ramesh, let me move the discussion now to this is all well and good. Tell us, what's the current state of the technology? Meaning, how much of this is like in real world use, if you will, at least on the business side? Because I think there's been a lot of hype around cryptocurrencies, as you said, permissionless. But on the permission side, can you give us a snapshot of the current state of the world?
Yeah. So in the grand scheme of things, these are early days of a technology, right? It'll take years to get it to, a level of maturity where it's, universally deployed, let me put it that way. But that being said, I can tell you my own journey over the last 3 years, right? So when we started in 2015 with this idea, we got to build a blockchain for business, right? Ethereum and Bitcoin doesn't quite cut it, right? So we had to build the basic technology elements. And so we spent a lot of time, putting together from scratch a blockchain, for business, if you will. And that's what we contributed to the Linux Foundation's Hyperledger project. It's basically what became Hyperledger Fabric, and now it's a community that's developing the technology. So the technology is, 3 years old, let me put it that way, right? Roughly. So it is early days. That being said, much of my time I've not spent on just the raw technology. I'm sure there are plenty of cryptographers and distributed systems folks, they'll figure it out. My focus and my team's focus has been on, how do I use this new database to solve real business problems? And so one of the first problems I decided to go explore is how to make food safe. And why go after this problem space? Very simple, right? If you look at food, right? Just by the way, this is a universal problem. Food recalls, people getting sick with food. It's a significant issue, right? Or let's talk about food waste. In India, there's tremendous food waste. Globally, 1/3 of all food is waste. Food freshness, right? If you buy something like meat, you want to make sure that it, if you eat meat, that is, you want to make sure it's fresh and it's okay to eat. All of these questions are solved by collaborative information sharing between various players in the food ecosystem, from the farmer to the packing company, to the supplier, to the retailer, getting it to the end consumer, right? Farm to fork, as we like to call it. That collaboration requires, an interesting database, and that's where blockchain comes in, right? So we've basically been working on food safety, as one example, and the way it started is 2 years ago. I flew to Bentonville, Arkansas, and said, "Hey, Walmart, I think it would be a great idea to use this technology." And 2 years later, now we have a product called IBM Food Trust. And more interestingly, Walmart has mandated that all suppliers of their leafy greens, spinach, lettuce, etc., have to be on IBM Food Trust, right? So tremendous, change from 2 years ago to now. So even though it's early days, my point is, there are examples where you have blockchain solutions in production for more than a year. So IBM Food Trust has been in production for more than a year with Walmart, Carrefour is the #2 retailer in the world, have also joined the system. So in balance, the way it is, early days, but there are examples of production systems like IBM Food Trust, TradeLens, WeTrade, and not just all from IBM, by the way, just to be clear. Plenty of others are going to production too. But we have moved away from kick the tires experimentation 2 to 3 years ago to now actual production systems, but very few of them. So it's early days.
Got it. And I believe the next slide or two specifically around food safety and your food use case, or what are we looking at next?
Yeah, so there are a couple of charts there, but I think given that time, maybe we shouldn't go to the charts. But I can go to the questions. Yeah.
Sounds good. So what do you what are the unsolved problems? What do you think is still coming in the way of blockchain gaining wider adoption? One of the things I've heard is that it's pretty compute and actually more so bandwidth intensive, in that these distributed databases, ledgers, you have to keep it up to date, and so on and so forth. Energy consumption. Can you talk about some of the issues? What's coming in the way of blockchain catching on? And the other is when you have multiple parties involved, everybody has to buy into it, right? That can also be a problem from a real world perspective.
Yeah, excellent question. So much of the problem with respect to raw technology, whether it be scalability, privacy, confidentiality, energy wastage, etc., are all in the permissionless world, really, right? And the reason for that is, I'll give you the intuition. If you look at anonymous participants running a database, they got to come up with some mechanism, right? So that they know which is the next transaction that's been committed and everybody agrees. The approach that was taken in Bitcoin was something called proof of work, which basically solves a mathematical puzzle, which is very expensive to solve and makes no sense to solve. Let me add that too. So that's the world where you have some technical challenges which people are trying to solve, and with innovative approaches. There's a lot of innovation in the permissionless world. I don't want to, don't want to discount that. That's that world. But if you move over to the permissioned world, much of those problems go away, because if there are 10 companies running copies of a database and they need to update something, you can imagine a protocol that talks to each other, and there are distributed algorithms going back to 20, 30 years, Paxos, Leslie Lamport, Raft, what have you, that makes that possible. So in some sense, much of the core technology basic problems, I think, are much easier in the permissioned world. Okay, so that's one point I want to mention. That being said, I think the biggest challenge, which unfortunately the students may not be as exciting, is the last point that you made, right? If you have, all the companies in the food ecosystem, retailers, suppliers, farmers, all on the same system, they all need to get business benefit from it, right? And different parties will get different benefit from it depending on their role in that ecosystem, to use a term that's used a lot. So getting the ecosystem right, getting the business model right, so that everybody benefits, getting the governance right. After all, it's a database that's shared by a lot of parties. Who owns the data? Who can do what with the data? These are all questions that have to be answered too. So there are a lot of challenges which I would call our business challenges more so than technology challenges. But on the technology side, just to make one last point, there are tremendous opportunities to bring in things like zero knowledge proof, to get these smart contracts, which are sort of business logic running on top of this database, to be extremely powerful. Is clearly a space. There's plenty of opportunity there. In fact, there's a lot going on in IBM research also specifically to solve these problems, technical challenges.
Wonderful. So, and I think we're at least out of time as far as my questions are concerned. Let's open it up to the students. Arvind, if you want to have any of the students come up if they have questions. And I know there's some questions in that notebook, that online Google Doc, so we can.
Yeah, so I'm just opening the Google Doc first.
Okay. All right.
Just a minute.
So we had some very detailed questions from at least one of his students. He seemed to be very interested in this topic.
Okay.
I can put it up here too. But Ramesh, you can probably see it on your side as well. I think it's Ashutosh, if he's there.
I don't think Ashutosh is here, but I think I'll read out the question. Oh, he's written quite a few questions. Yeah. I think the first one is absolutely relevant because if I understand right, the NPTEL, which is the online lectures being offered by the various IITs and IISc, have a course next semester on blockchain, and we have actually tried to include that as part of the allowed electives for our students. Just waiting for the final permission on that, but I think we have started the process there. And so I think it'll be nice to hear Dr. Gopinath's opinion on the first question. Is it the right time that institutions should start offering blockchain and cryptocurrency as an elective?
So, the way I look at these things is in terms of what does the world need in terms of skills to solve problems, right? Given the fact that, there's tremendous excitement around blockchain to solve business problems like food safety, etc. We look at, do we have enough skills? And the answer is there is a huge gap in terms of skills, blockchain skills, to help solve these problems. So therefore, I'm absolutely all for academic institutions bringing blockchain curriculum into into bringing blockchain to their curriculum. That being said, I think I would mention that both the permissionless and the permission varieties should be taught because I think businesses are moving fast with the permission blockchains, and I think it's getting tremendous amount of traction and focus. And so we need those skills. The permissionless world is interesting too, right? So I would cover both topics. So that's the only thing I would make. Other than that, it's a great idea. We do need more blockchain skills, no questions in my mind.
Thank you very much. I think we'll take a few questions from the audience here and then go back to the list.
Absolutely.
So we have a student, Vishal.
Good morning, sir.
Morning.
Thank you for taking time out of your busy schedule and talking to us. So actually, I have some experience with Bitcoins because I tried mining Bitcoins. And one thing which I noticed is that in order to know the balance in your wallet, it takes a lot of time to actually update the balance. It's because it has to go through all the databases and get some verification signature. So how should we reduce this latency?
So so this is a question that I'm not best suited to answer because most of my time is spent on the permissioned blockchains, like I said. But there are, this is a simple online search for you because there are plenty of people who play with Bitcoins that I'm aware of who don't have a significant latency from using their wallets. So you should, in fact, there are wallet services also out there, right? You can look for, part of it could be you are using the right wallet service perhaps, right? But this shouldn't be a problem for you. Bitcoin transactions can happen fairly quickly, right? When I say quickly, I don't mean instantaneously. I mean of the order of, it should settle in a few minutes, right? Tens of minutes.
Okay, thank you.
All right, thanks. So I think there's some other questions all around blockchain. So let me see if Dr. Arvind, you wanted to bring up any of these others that would be of interest to the students at large. Please go ahead.
Yeah, somebody's coming up.
Good evening, sir. I'm Vishnu from Electrical Engineering branch. I had a question. Basically, on one hand, of using one of the advantages of using blockchain is the increased reliability, because of the fact that a lot of redundant data is being shared among several nodes, so you can verify with several nodes before you actually determine whether something is true. On the other hand, you also have a lot of redundant information because of the very nature of blockchain. So how do you how in what balance is this trade-off shifted in? Is it do the benefits of reliability overcome the cost of increased redundancy, or how is this how is this balance actually shifted?
Yeah, this is a fantastic, great question, by the way. I really appreciate the question. I think your intuition is right, right? So if you look at the permissionless world like Bitcoin, Ethereum, etc., there are so many nodes. All nodes have an identical copy of the data. It is overkill, no questions, right? From a reliability perspective, you might want to have 10 copies, not 1,000 copies or hundreds of thousands of nodes keeping the same data. Makes absolutely no sense. It's inefficient, right? From an intuitive perspective. So what's going on is, if you look at the permission blockchains, what we are doing is, in terms of the number of nodes required to build enough trust so that there is no collusion between the parties, it could be of sort of tens of copies, 10, 20 copies. That's what we do in IBM Food Trust, for example. So the redundancy is a lot smaller than you would think what would happen in a open permissionless world, right? So the right answer here is, you got to look at it from, don't get caught up in the hype of blockchain, but ask the question, what is the business problem you're trying to solve? And if you're solving this business problem, how much redundancy do you need? To ensure that there is no collusion, right? So you decide on a number that makes the most sense. What level of non-repudiation do you need? So these are really, so for me, it's not like one blockchain solves them all. You really try to figure out, okay, I have all these properties that I need to solve my business problem. What is the closest blockchain that is appropriate for it? And how much redundancy do I have in it, et cetera, et cetera. So most engineers in companies like SAP, Oracle, IBM, Microsoft, et cetera, they are approaching it this way. And sure enough, they're not going to have thousands of copies of the same data sitting around and just unnecessarily taking up resources.
Yeah, but Ramesh, just to follow up that, collusion is the real problem there, right? Because if you say there's only about 10 copies, how do you make sure the parent companies or the ultimate entity that owns those copies, controls those copies, is not the same organization? How do you make sure those truly are organizations that are independent of each other and not going to collude?
That's exactly correct, Mani, right? So what you want is a set of companies who are completely independent from one another, not subsidiaries or whatever, who have access to the nodes. And typically what you do is take food safety, right? We will have not just Walmart, but also a competitor like Carrefour, right? Kroger, etc. So you bring in competitors on the same platform to run nodes. Chances of them colluding are fairly small, and you want it to be a reasonably big number so that the chance also reduces of colluding. So 10 to 20 is a reasonable number in my view.
Got it. So yeah, that's as you said, that's an important part of the negotiation and agreement on the parties involved who own these distributed copies.
That's right. And I want to. Sorry, go ahead.
Please continue. I just have one more question. So basically, this blockchain is kind of a decentralized system. So how do, say, law enforcement officials kind of enforce certain general finance rules in something that is kind of a decentralized system? Like you can have, even though there are distinct parties in the blockchain system, they can come to consensus and do something legal, which is not according to certain financial rules. So how can law enforcement officials actually kind of ensure that the financial transactions that are happening within a blockchain system are according to certain general rules?
Yeah.
Or is it a problem? Or?
Yeah. So it comes down to a basic insight, right? If you look at the permission world, you know the identity of all the companies or parties that are running nodes of the blockchain, right? So therefore, these are legitimate legal entities. So the governments know who is running what. In IBM Food Trust, everybody who runs nodes is known. Once you know the identity, of these legal entities who are running the nodes, the government can actually subpoena or ask for, if something is fishy or feel that something is going wrong, they can actually, intervene, right? The advantage, one of the biggest advantage of permission blockchain is you can fall back on the legal system. Now let's go to permissionless world, right? There is this issue of anonymous participants are doing this. So you don't know who's doing what. So there is a problem with respect to what you just said. But the way this is going to be solved, and now I'm going to speculate, is governments are going to basically start regulating the permissionless world. And eventually what is going to happen is they will become semi-permissioned, right? You need to have some identity. For example, if you start moving Bitcoins, right, in certain jurisdictions, like in the US, Bitcoin is considered a security, meaning it's like, right, it's like a stock. I'm just trivializing it, but anyway, you get the picture. Because of that, right, it is regulated by SEC. So SEC can ask questions about, who's doing what transaction. So therefore, what do these companies who provision wallets, we talked about wallets earlier, do? They keep track of who's the player. So effectively, to make things work in this world, people are adding these levels of identity outside of the blockchain. So I think there's a lot of hype around, okay, this is, you don't need governments, it's an anarchic place, anti-establishment, all that stuff. But the reality is basically over time they will also get regulated. So net what I'm saying is, you can't get around governments. They have a role to play.
Thank you.
Okay, thanks, Ramesh. Thank you. Yeah, let me see if Arvind, we have more questions.
I think there's one more question from the students.
Okay, wonderful.
Yeah.
Hello, sir. I am Pratyush from Electrical Department. I am in currently the final year. So my question is not a technical one, but it's like, will countries or the central banks will create or will accept the blockchain currently? I see the trend that many of the countries are resisting. So if they are resisting, what is stopping them? And if they do accept, what will be the effect on us? What will be its effect, basically?
So this is a tough question, but I'll give you my point of view on this. Central banks really, control the money supply, right? That's what central banks do. So they're not going to, in my humble opinion, allow, a permissionless blockchain-based cryptocurrency play the role of money. I just do not see that happening at all, right? I see them supporting, a blockchain-based token or currency that is pegged to the Indian rupee, perhaps, right? In that case, the central banks will be overseeing and regulating it. That is possible. So in other words, the technology can be used to create, the equivalent of a digital rupee or a digital dollar. No questions, that's going to happen. But I don't think the Bitcoins and the Ethers of the world have a fighting chance of surviving if it becomes. So the reason why nobody's doing anything is everybody's watching it. It's such a small thing. Think of the global economy like at I don't know, $80 trillion or whatever, and think of the amount that is playing around in cryptocurrency. It's $200 billion. That's it. Tiny. It's like a drop in the bucket. Once they become important, regulators will take over, central banks will take over, and it will not look the way it is looking now. So that's all I wanted to say in terms of what your question is. By the way, your question is also relevant for permission. You could have permission blockchains where you actually also could have the equivalent of a US dollar rupee, done. That can happen today. Nothing stops us. The reason why nothing stops us is because if something goes wrong, the Reserve Bank of India knows, oh, it is that company or that bank that is running the node. Tell me what the hell you're doing, right? And so you can oversee it. That's it. Does that help? Hopefully this answers your question.
Yeah. Thanks.
All right, Ramesh. Before we wrap up, we'll see if Arvind has a question. But one question I did have is, and I want to make sure you address this, is what do you see as kind of the looking ahead? Looking at the next 1, 2, 3, 5 years. Where do you see this technology going? We can wrap up on that question, but before that, let me ask Arvind. Arvind, did you have any other questions from you or the students?
No, I think there are no more questions from this side.
Okay, so let's do that, Ramesh, and we'll wrap up this video.
Yeah. So what is blockchain doing? Why is it transformational across all industries? Right? I mentioned it's a new type of database that helps business across all industries. I expect blockchain to play a role in every industry, healthcare, education, whatever. You name your industry, blockchain will play a role, right? But over the next 3 to 5 years, what I see as the most exciting work, and I'll use the example of what we're doing with food as an example, right? What we are doing with blockchain and most companies are doing is creating this sort of collaborative platform for information sharing, right? In the food ecosystem, we are building IBM Food Trust. Similarly, other companies are building that. So over time, what's going to happen is plenty of data that's relevant to the ecosystem in terms of the flow of meat or strawberries or whatever, right, gets captured. That's and it's all new, interesting data that is at the intersection of companies, right? Which is not what is in company silos today. What does that tell you? It tells you that people will start doing AI on top of this data. I will try to make food waste reduce by using data in IBM Food Trust. I will improve the food quality by basically using data in IBM Food Trust, right? So effectively, what I see is application of AI, application of IoT to get data into the blockchain. So, for example, blockchain is trusted, but what about I'll give you a great example, right? So, supposing somebody basically is paid a bribe to send a transaction to IBM Food Trust. Does blockchain solve that problem? Of course not, right? So what we do is you basically come up with technologies where instead of transactions coming in from human beings, it comes in from IT systems like sensors. The best example I can think of is imagine that you have a retailer, Walmart, asking a company that supplies, let's say, chicken, right? I want you to do a test on the chicken before that you're shipping to me, right? So they stick some sort of a test equipment there. Instead of the test result being manually entered into IBM Food Trust, you want that equipment itself, say it's coming from some other company, 3M, let's say, directly sending the transaction to IBM Food Trust, right? So again, to summarize, AI, IoT, etc., will be what makes it interesting. After all, blockchain is boring at the end of the day, right? It's a database. You got to do something with the data. So that's where all the excitement goes.
Okay, wonderful. Any final words for the students as they look at this or any other technology area, trying to make their, figure out what they want to do, their life, their career? What are your final words for them?
Yeah, so I think my final words are just basically, it's probably cliched, but just follow your heart. Pick areas that interest you. Don't be very careful to recognize the fact that what you pick today may not be what you'll be doing tomorrow. That has happened to me so many times already. And so go in with an open mind, but make sure it's something that's interesting because you are spending several years of your life in a certain area, perhaps, right? So that's the other thing. And the last piece I would say is, to me, the thing that has kept me excited the most is, number one, always focus on trying to solve some business problem that, something that helps the world, right? So whether it be food safety or whatever. So that will keep you grounded. Regardless of technology hype, you'll be working on something that is interesting. Number two, the most interesting thing, you learn late in life perhaps is it's the people and the collaboration and, trying to work together to make something happen. That's the most exciting thing, rather than just, one specific technical problem or the other. Yes, they are important, but they're important in the context of the broader solving, problems for, and making the world a better place.
All right, guys, you heard it from Dr. Ramesh Gopinath. Enjoy your life. Hopefully you'll get to your finals. And Dr. Arvind, are we good to wrap up at this point?
Yeah. Okay. Thank you very much, Dr. Gopinath. Thank you, Mr. Iyer. And thanks all for joining us today. I hope this sets you thinking about blockchain and maybe some of you will come up with some interesting products. Thank you very much.
Thanks. All right. Bye.